Okay, in this video, we're going to work with events. Now this is quite important because events are a first-class feature in C#. They're so important they're built into the language, and they're really the backbone of GUIs. So without further ado, let's begin. Let's say we want to have a person who wakes up when a rooster crows. So let's make a couple of classes to represent that. So let's have a rooster class, and we're going to give it an event. Public event, event handler, caw. Okay. And we're going to have a public void to caw. We're going to... Okay. So let's stop for a second and explore what all this is doing. So what happens is events have subscribers. So what events allow you to do is whenever the caw event is invoked, and this is what it looks like when the caw event is invoked, all it'll do is it'll say, okay, I don't know who is subscribed to me. I know I have a list of subscribers. I don't really care who they are, but I just want all of you to know that I'm raising this caw event. So this helps you decouple, logic in places where it shouldn't have knowledge of both sides. So this is handy for GUI stuff, because the GUI shouldn't, directly know how, the business logic works, and the business logic shouldn't necessarily directly know how the GUI works. There should be some layer of indirection between them. So that's what this allows us to do. Now let's form the person class now, actually. So we'll just have a class person, and we'll have a public void, and we'll say say I'm up. Object O, event args E. Let's have him console.writeLine. I'm up. Okay, so event tells us that we can have subscribers. Event handler is the signature of the subscribers. So what happens is whenever this is invoked, the event has a list of methods that conform to the event handler delegate, and it'll just go through and run them all. It's basically just a list of methods, a list of event handlers. So notice, this is just a delegate. This is a delegate that returns a void type, and it has object sender and event args E as its arguments. So if we look, that's exactly what our signature is here. We don't have to use event handler. This is standard. What people will often do is they'll extend event args and have them contain, the pertinent information, that they want to send over. The event args, the object sender, you're always going to call that with this if you're using the regular C# event syntax. And that just tells you who raised the event. The event args contain all pertinent information and state that might be relevant to processing down here. So we could have this guy, whenever he says do caw, we could have him send the time and have this guy say, I'm up at this time. Albeit, we would have to create, a myEventArgs class that extends eventArgs and add a time field that we could access. So let's back up a second and let's simplify this a bit by making our own delegate here. And in fact, let's use the Action Delegate, because it's nice and easy. It returns nothing, it requires nothing. So, if we look, what we can do is inside of our main, we can make a rooster, var rooster equals new rooster, and we can have a var person equals new person. Now, what we do is when we want to add subscribers, we say rooster dot, and see, the little lightning bolt is an event. So we say rooster.caw, and we want to add a subscriber. That is, we want to add something. We want to add a function to run whenever the caw event is invoked. So we're going to add a person, say I'm up. Oops. Because this is a delegate, we do not need to add the parentheses after this. And because these signatures match, it can be added to it. If we had an int I here, notice it doesn't like that. This is expecting, see, it'll tell us, this is expecting an action, and this isn't an action. Actions return a void and take in no arguments. Okay, so what we can do is we can say rooster.doCaw, and what'll happen is it'll run this. Now that's not exactly entirely the truth. If we look at this event, it's not being initialized to anything. This event is null right now. So what we want to do is we want to check if caw is not null. Oops. Now we're not going to use null propagation. If caw is not null, then we're going to call caw. So this will avoid a null reference exception. Whenever you add something to it, what this actually does is allows you to chain. You can daisy chain as many functions as you want to this event, and this will set it to something that isn't null. So what we'll do is we'll add a print statement here so we can see. We'll say console.writeLine not null, and we'll add a console.writeLine null in here. And we'll add a rooster.doCaw before we add a subscriber, and a rooster.doCaw after we add a subscriber. And if we run, oops, can't forget our console.read key. If we run, we see that there's a null because we didn't add a subscriber, so this is uninitialized. Then in the next line, we add a subscriber to the caw. Whenever the rooster caws, it doesn't care who's listening, but the person cares when the rooster caws. When the rooster caws, they say that I'm up. They say that they're up. They wake up. So since we added that to our event caw, it's no longer null. So that's why it prints our not null here, and it invokes the caw action. So it looks through all of the subscribers of caw, and it goes one by one, and it runs them. Note that I do not believe that this runs it in a separate thread, so don't think of this as multi-threading. I'm pretty sure this is synchronous. So then it'll run I'm up. So that's why we see exactly this. Null, and then not null, because we added a subscriber, and then I'm up, because that's the result. That's what the subscriber does when it sees an event. So events are also handy because they can, communicate cross threads, and the UI thread with forms is separate from your processing thread, your business logic thread, and that's just sort of how everything is organized. But it's a convenient way to decouple what's going on. If we didn't do this, all we would have to do is we could maybe pass an action into the doCaw method, and then that would be ugly because we would handle, a list of events ourselves, and that means Rooster would have to know about, all of its subscribers directly, but, event adds another layer of indirection. And this is a pretty fundamental concept in C#, so, do your best, do some experimentation, see if you can work around this. Now, another important thing that I want to point out, oops, I can stop the program. You can add access modifiers, basically, for an event. So, let's see if I remember how to do this. So just like set and get, we can have an add and remove. And what this will do is this will override the plus equals method. And it uses the same, value keyword. So if you want to add a custom handler, you can look up how to do this. You might need one. I'm almost at the time limit here, but you can look up how to do that. It's really easy, and it can be quite helpful. And you can, define events and interfaces as well. So that basically concludes events. If you have to go through this maybe one more time, I would recommend you do so, because events are so useful once you get a hang of them. And that's about it.